Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph exponential equations. And we're going to graph exponential equations that are in the form of y equals b to the x, which are the first three, and then also, and down here and down there, and also equations that are in the form of y equals a times b to the x. Now it's important again to understand that b represents the base of the exponent, x represents the power of the exponent, and a is going to be the coefficient. So you can see here, let's see, 3 is a, b is 1/2. And then we have negative x here as our power. Now, it's very important because to be able to distinguish them, because a lot of times students get confused. But just remember, a is not being raised to that power. Now, if we don't have an a, remember we can always take a look at saying my a is going to be 1 in front of that. And also, I just pointed out the exponential equation e, because e is a number. It's not representing a variable. And we'll talk more about that later on. Now, you notice I don't have graph paper, right? I'm just going to be sketching the graph. So I'm not going to be very exact, but basically what I tell my students, obviously using graphing technology, graphing calculator or your phone or a computer, you can understand, exactly what the graph looks like. And if you want to spend more time, you could create a table, which we're going to do for the first example, just to kind of get an idea of how to always take a look at the graph to get it exact. But for this video, I'm not going to be concerned with finding the exact value of what the graph is going to look like. I'm just going to kind of get a rough sketch based on the transformations. All right, so the main thing, though, I want to kind of look at here is I'm going to graph this third one, this graph, and to kind of draw some understanding, basically, of what the exponential graph is going to look like. So one thing I always tell my students is if we want to graph something, the best and easiest way to always graph, no matter what function we're dealing with, is to create a table. And I'm just going to do this for the first example, just so you can kind of get an idea. So let's just kind of pick some numbers, and I'm not going to go crazy. Let's just do this. This, I think, hopefully will give you a good idea of what we're doing. Now, these are going to be the x values I arbitrarily chose. You could choose any values, but these values are pretty simple for me to be able to plug into x to find y. So if I did y equals 3 to the negative 1, that equals 1 over 3 to the 1, which equals 1/3, which is like 0.333, right? And I'm going to use the decimal approximation because I want to graph it. And sometimes graphing fractions gets a little confusing for students. So I think if we look at them as a decimal, it'll be a little bit easier. Y equals 3 to the 0. Any number raised to the 0 power is going to equal to 1. Y equals 3 to the first power is just equal to 3. And y equals 3 squared is equal to 9. Okay? Now, if I simply just wanted to plot these points, what I'd have is at negative 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So at negative 1, I'm only up 1/3. At 0, I'm at 1. At 1, I'm up 3, 1, 2, 1, 2, 3. And at 2, I'm up 9, all the way up there. Okay? So what you can see is as we're going to keep on going, this graph is going to keep on getting larger and larger. And if I would have chosen negative 2, what that would have given me is 1/9. So at negative 2, I would have gotten even smaller and smaller. And what we'll notice is, as you keep on going farther down, again, you can use graphing technology for this, what you'll do is you're going to get closer and closer to 0, but we're never actually going to approach 0. So what that creates is what we call an asymptote. The graph is approaching 0, but it's not actually ever going to reach 0. So that creates an asymptote, which we use to represent as a dashed line. Now, you can see on the other side, as we're going to positive infinity, what this graph is going to do is ever increase. So if I just wanted to kind of sketch this graph, it's going to look something like that. Okay? Now, that's for y equals 3 to the x, which I guess I probably could have just graphed right here because I wanted to do something else over there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Okay, so that's that graph. And I'm going to graph the asymptote because the asymptote is a part of the graph. And that's one thing that a lot of students kind of forget is they don't graph the asymptotes. And what happens is that starts to confuse them once we start talking about domain and range, which we're going to do for all these problems as well. All right, so that's going to be our table. That's graphing that one. But you can see that kind of took some time. And yes, we could do that for every single one of these. But obviously using a graphing calculator or graphing system would be preferred because it's much quicker. But we can also just use our understanding of transformations to graph these very quickly without having to whip out a calculator for every single problem or tedious in time as far as having to create a table. So our basic understanding of creating a table there's some general relationships of the exponential functions, either in y equals b to the x and y equals a to the bx, that we can remember to at least plot one point. And that's all I ask for my students, is to have at least one point that is represented, and then to kind of represent the asymptote and what the graph is going to look like. And that can be easily done based on our knowledge of transformations. So here is what we call the parent graph. The parent graph is when we have no transformation. So if we just have an equation y equals b to the x, where b represents a real number, the graph is always going to cross at 0, 1. Always going to cross at 0, 1. At 1, the graph is always going to, when 1 is your point, then your y value is going to be b. Now, this is 2 points, but you could choose either one of those. And the asymptote, again, is going to be at 0. So the graph is going to look something like this. Okay? On the contrary, if we were to look at a problem, this isn't a really good problem to look at, but let's look at this problem. On the contrary, if we have an equation that's in the form y equals a times b to the x, let's look at what happens when we plug 0 in for x. So 1/2 raised to the negative 0. Negative 0 is not negative or positive, so now that's 0. So 1/2 raised to the 0 is just 1. 1 times 3 is 3. So when x is 0, y is 3. So what that's telling us is, when we have an equation in the form y equals a times b to the x, the graph now crosses at 0, a. So whatever that coefficient is, because remember here, it is crossing at a as well. That a is just always 1. Well, now, if you have a coefficient, the graph crosses at a. And I don't want to get too confusing over here, but if you did 1, 1, that would be a times b is going to be your coordinate point. And again, it's going to look, it's going to look kind of exactly the same. Okay? Now, I forgot to mention, these are all when b is greater than 1. If b is less than 1, then the graph is simply reversed. And you can just think about that. B was less than 1. Now the graph is reflected. And we're going to take a look at that a little bit as far as our transformations. Y equals b to the x. So if b is less than 1, the graph now is decreasing. And again, we can show that by using graphing technology, but that's not going to be the purpose of this video. But you can always double check your answers by using a graphing calculator or a computer to verify your results. But I'm going to kind of work these a little bit quicker, just understanding transformations, as well as my understanding of the two parent graphs. So hopefully you'll wrote down those two parent graphs, or you have an example of them, because that's going to be the easiest thing to follow as I kind of work through these multiple examples. Now, the last thing I want to talk about is the domain and range. Remember, the domain is the set of all x values that make up the graph. Well, I could have chosen any x value. I guess I shouldn't have erased my table. But I chose x values. Every x values that I plugged into x, I found a y, right? And I can't think of an x value that I can't plug in for x where I'm not going to get a y. And that's represented by noticing the graph goes infinitely to the left, and it's going to go infinitely to the right. Even though it's getting really high, it's going to keep on going to the right. So the domain is negative infinity to infinity. But the range, as you notice, that asymptote, remember we said those as x got negative, the values for y got smaller and smaller to 0, to almost to 0, but they never got to 0. And also, they never go below 0 as well. So the range is going to be from 0, and it's going to be a parenthesis because it's not actually ever touching 0, to infinity. Okay? All right, so again, I'm not going to get very detailed with my graphs. I'm just going to kind of go quickly through this. So in this case, I have my a is 1, so I know it's going to look like my first parent graph that I had. However, 2/3 is less than 1. So by graphing this, I'm going to go up to 1. But now my graph is decreasing. Again, the 2/3 is going to be different. The 2/3, if it was 3/4, that's all going to affect the graph, but I'm not going to worry about that for now. I just want to get the general form of the graph based on the transformations. The graph is going to look something like that and have an asymptote. The domain, again, is all real numbers. And the range is still from 0 to infinity. Okay? In the next example, E represents a number, 2.45, I believe, 2.67. I can't really remember, and I don't have my calculator. Oh, yeah, we actually do have it with me. Should remember it, but it is the summertime, so let's see. E, 2.71. Sorry about that. So E represents an irrational number. It's around 2.71, which is greater than 1. I see my A is at 1. So that means I'm going to cross at 0, 1. And the graph is going to be increasing, so it's going to look something like this. Okay? So now that's going to increase. Since my B is a little bit smaller than 3, it's not going to increase as fast as a 3. Obviously, the larger the base, the faster it's going to increase. But in this case, all we're going to do is now determine the domain and range. The domain, again, is from -infinity to infinity, where the range is from 0 to infinity. Okay? Now in the next example, we have 2 times 2 raised to the x. Again, we see that we have an A. A times b to the x. So since my A is 2, now the graph is going to it's going to have a y-intercept at 2. However, that does not shift the graph up 2. It's just having now a y-intercept at 2. My base 2 is still larger than 1, so the graph is going to still look like this. It's still going to have an asymptote at 0. So all that 2 does is basically just kind of change the new y-intercept. However, the graph is still approaching 0, and it's still going to be increasing because b is larger than 1. So my domain and range is unchanged. Okay? All right, so now let's get into a negative here. Now, the main important thing I like to remind students is there's 2 different types of transformations that we have. And typically when we get into, let's see, well, I'm not sure where you might have gone through, but when we deal with quadratics, when you deal with like quadratics, you have y equals x squared is like the U-shaped graph, right? Well, y equals negative x squared, now the graph is opening down. So when you're multiplying a function on the outside by a negative number, what that's doing is that reflecting about the x-axis. On the contrary, we don't really deal with it that much. But if I had y equals negative x squared, well, that's going to be a reflection about the y-axis. Now, for a quadratic, the graph looks the exact same because it's symmetrical about the y-axis. However, if I had a graph, for instance, if I had y equals square root of x, that looks like that, whereas y equals negative square root of negative x, then that graph looks like that. Okay, so it's a reflection about the y-axis. Well, in this case, you can see that I'm multiplying a negative on the outside. Okay, so typically what we like to do is graph the function first and then apply the transformation. Now, we notice that my a is going to be 1. Forget about the negative for a second. We know a is equal to 1, and we notice b is a fraction, but it's 4/3, which is greater than 1. So therefore, the graph is going to cross at 0, 1. And it's going to look something like this before I apply the transformation. Okay, now the asymptote, again, is at 0 still. But now once I apply the transformation of multiplying by negative, that's going to reflect it over the x-axis. So now, instead of it crossing at 0, 1, it's going to cross at 0, -1. Still going to have an asymptote at 0. But now the graph is going to look something like that. Okay, now this is very important because now our domain and range are going to be affected. Our domain is still going for all infinitely to the left, infinitely to the right. So that's going to be -infinity to infinity. But my range, now my graph is below 0, right? And it's going to keep on going lower and lower and lower to -infinity. So my range is from -infinity, and it looks like it's trying to get higher and higher and higher, but it's not going to get past 0. So my range is from -infinity to 0, which is different than every other result that we've had. The next one, we have y equals 1/2 e to the x. Okay, so this is kind of like my last, this example. Instead of my a is not 1. So if there's 1, my a is 1/2. So that goes right there. All right. Oh, well. So my a is 1/2, and let's see, it's still going to have an asymptote here. And it's just going to look something like that. So the a is only affecting that 1/2. Okay, that's fine. My domain is going to be from -infinity to infinity. My range is going to be from 0 to infinity. All right, a negative, now you can see that the difference between having my negative as in my exponent compared to my negative on the outside, this is considered me multiplying by a negative inside of the function. See how this is being multiplied inside of the function? Well, if I was going to show an equation where it being multiplied outside the function, it would look like this. Okay? Outside the function, inside the function. Inside the function, outside the function. When you're multiplying by a negative outside the function, that reflects over the x-axis. When you're multiplying by a negative inside the function, that reflects about the y-axis. So again, what I like to do is graph before the transformations and then apply the transformation real quick. Okay? Cool. So y equals 4 to the x. That's going to be increasing just a little bit faster. Again, it's going to be faster than 3 to the x. It's going to be faster than 2 to the x. It's going to be faster than e to the x. But again, just I'm only concerned about 1 point, which I know my 1 point is going to be at 0, 1 because a is 1. So I go up to 1. It's going to graph like that. However, remember, I got to reflect this about the y-axis. Now let's write in my asymptote as well. So if I'm going to take this graph and reflect it about the y-axis, basically everything is going to be flipped around that y-axis. Now, the y-intercept remains the same, and the asymptote is not going to change as well. And if you remember when we looked at this, these two graphs, kind of look pretty similar to each other now. And that's exactly kind of what happens. Remember when you have something raised to a negative power, that puts it in the denominator, which makes a fraction, which is less than 1. However, the domain and range are going to remain the same. -infinity to infinity, and my range is from 0 to infinity. Okay, last but not least, we have y equals 3 times 1/2 x raised to the -1/2. Again, we see that my a is 3, so I'm going to have a y-intercept at 3. However, my b is 1/2, so that means I know my graph is going to be decreasing, and I have another negative reflection. So my graph is going to look something like this. Okay, but now if I reflect about the y-axis, that means my graph is going to look something like this. Okay, again, it's going to be approaching my asymptote. It has a intercept at 3, and it has its reflection. The domain is going to be from -infinity to infinity. And the range is going to be from 0 to infinity. Okay? So there you go, ladies and gentlemen. That is how you graph exponential equations when they're in the form y equals b to the x and y equals a times b to the x. Thanks.